So as we have talked in the intro video that we will be working on a real conveyor. So in this video we are going to start our project, and this video is related to the wiring explanation of all the stations on the conveyor, and that how sensors are sending data to Arduino on different stations, and how Arduino is sending data to a single OPTA, and how that OPTA is controlling the motor of the conveyor through a relay at output 1. So the components required will be Arduino OPTA, 2 Arduino Uno, 4 IR sensors, and specifically I will be using the IR sensors that are HW201. One color sensor, and its name is TCS3200. Some connecting wires to send data and to power the sensors and Arduinos, and Arduino IDE software for programming the Arduino Uno and Arduino OPTA. So the process overview, I have already told you that the sensors from different stations will send data to Arduino Uno, and the Arduino Uno will be sending data to a single OPTA, and that OPTA will control the conveyor. So this is the Arduino Uno 1 connection with sensor and Arduino OPTA, and this Arduino Uno will be linked with the first station. So let's see the wiring. The VCC of the IR sensor will be, this is the IR sensor. Let me choose another color. The VCC of the IR sensor will be connected to 5 volt on the Arduino Uno. So here you can get the 5 volt. So this is the VCC pin, or I guess this is the VCC pin. It differs on model to model, so you have to see there is the marking for VCC, ground, and output. The ground of the sensor will be connected to the ground of the Arduino Uno, and the output pin of this is the output pin. The third one remaining is the output pin. This will be connected to the digital pin 2 of Arduino Uno. Similarly, we will have 2 IR sensors. So you have to similarly give VCC and ground from the Arduino Uno, and its output pin, I am talking about the IR sensor 2, its output pin would be connected at the digital pin number 3 here. So one sensor will send data to digital pin number 2, and the other will send data to digital pin number 3. We will use the sensor that is attached on the digital pin 2 for the product count, and this sensor will stop the part as it reaches on the station 2 for the color sensor, and we will discuss that in the next station. So for now we have 2 other IR sensors also connected with this Arduino Uno. After the color is sorted out, the blue color will stop at its specific position, and a green color will stop at its specific position. So these 2 IR sensor will be linked with their specific color. So this one will be linked with the green color, and this IR sensor number 4 will be linked with the blue color. Whenever a green color is detected by the color sensor, whose wiring will be discussed in the next slide, the Arduino OPTA will look for the value of this IR sensor. As this IR sensor is triggered, it will stop the motor. It means that green part will stop on its respective position, and similarly for the blue, when blue color is passed from the color sensor, the OPTA will only look for this IR sensor number 4. It will not look for this IR sensor because it's linked with the green color only. So whenever the color is blue, OPTA will look for this IR sensor reading, and it will stop as this IR sensor is triggered. So the blue color will be stopped on its respective position. You can change the working of these 2 IR sensors by just replacing the digital pins on which they are connected. So this digital pin, this IR sensor will be connected to D4, and another IR sensor will be connected to D5. By connecting the IR sensor to D4 or D5 means that their output pin would be connected to the respective digital pin of the Arduino Uno. You have to give 5 volt and ground. Similarly, I have taught you before for the IR sensor one. You have to give the power from the Arduino Uno to all of the 4 sensors. Now, as this IR sensor is triggered, it sends data to its respective pin, and we have programmed our Arduino Uno in such a way that whenever the pin number 2 is triggered, whenever the data comes on the pin number 2, it make its digital pin 7 high, and this high is recognized by the Arduino OPTA as a signal. So we have connected this digital pin 7 to I1 of the Arduino Uno, this digital pin 8 to I2, and this digital pin 9 to I5, this digital pin 10 to I6. You can see here, you can see all the wiring here. Here is all the wiring explained if you can't understand it through my drawing. And finally, the ground of the Arduino Uno and the ground of the Arduino OPTA must be common. For sending a high or low signal, it's necessary that you should common both grounds. Otherwise, the signal will not be detected by the OPTA. Although Arduino Uno is sending a signal, but OPTA will not receive any signal. So moving towards the station 2 consists of a color sensor, Arduino Uno, and this is a separate Arduino Uno, and all the wiring of the color sensor is explained here. The VCC to 5 volt. VCC of the color sensor will be connected to 5 volt pin of the Arduino Uno. Color sensor ground to Arduino Uno ground. S0 pin to digital pin number 8. So these all are digital pins of the Arduino Uno. S1 to digital pin 9, S2 to digital pin 12, S3 to digital pin 11, out pin to digital pin 10, and the OE pin to ground. Whenever the color is detected, Arduino will send data from these two pins, D2 and D3, which means digital pin 2 and digital pin 3. As a green color is detected, it will make its digital pin 2 high, and as a blue color is detected, it will make its digital pin 3 high. So we have to connect the digital pin 2 to the I4 of the Arduino OPTA and digital pin 3 to the I5 pin of the OPTA. These are the input pins. So, but the OPTA will not receive a signal yet because we have not commented the ground. So it's necessary to have both grounds common. In this way, it can recognize that it's a high signal or a low signal. So let's move towards the practical demonstration of the wiring.